So this is the last video of derivatives that we'll be talking about today. So the last example is f of x is equal to x squared minus 4x. And letter A says sketch the function and the tangent line to the graph at the point where x is equal to 3. So here I have the function already graphed, and I'm going to go ahead and graph this function on my worksheet. So I have here two zeros, one at 0 and one at positive 4, and the lowest point seems to be at 2, negative 4. So I'm going to try my best to draw that accurately. Here's 1, 0, here's another 0, 1, 2, 3, and this is 4, and 1, 2, 3, 4. Here's my minimum. My graph looks something like this. Okay, and then it says, and the tangent line to the graph at the point x equals 3. So here's 3. Don't know what that point is, but you can graph that point by plugging in 3 into your x's here. Okay, and we have to graph the tangent line. So it's just a sketch. It doesn't have to be perfect, but we know that a tangent line crosses the curve at one point, so it would be something like that. Okay, and this slope of the tangent line, this slope has a rise over a run. Okay, and we know that the slope of the tangent line is the derivative. Okay, so letter B. Based on your sketch, do you expect f prime of 3 to be positive or negative? In other words, f prime already stands for derivative. So f prime of 3 implies the slope of f of x at x equals 3. Now, looking at this slope, just like we read a graph from left to right, is this slope a positive or is it a negative? And the way you determine that, you follow the linear function. Well, from left to right, it is going up, so it's a positive slope. So the answer is positive. Compute f prime of 3 three different ways by using the definition of derivative, the alternate, and using the shortcut from the last problem. Okay, so let's go ahead and use the first way. So we know that the derivative is as the limit as h approaches 0 of f of x plus h minus f of x. Okay, all over h. So that is the function is x squared minus 4x, so it's x plus h squared minus 4x plus h, and then minus the function itself, which is x squared plus 4x all over h. So square the binomial, so it's x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x all over h. So, and we see that once we're done multiplying everything out, you'll notice that x squared cancel, 4x and 4x cancels, and we're left with the limit as h approaches 0, 2xh plus h squared minus 4h. Okay, so then we know that we have a common factor of h on top. I can cancel one h at a time. So it's it's the limit as h approaches 0 of 2x plus h minus 4. No longer all over h, since we already canceled the h at the bottom. So now we can apply the limit safely, and we know that our derivative, this is our derivative, f prime of x. But we want to find f prime of 3. So that means I simply plug in 3 right here. 2 times 3 is 4, gives me a 2. So this slope, this tangent line that I drew on this parabola, is supposed to have a rise over run. The slope is supposed to be 2. Let's go ahead and verify this by using the alternate form of the derivative. So the alternate form is f prime of c. It's f of x minus, well, I forgot the limit. The limit as x approaches c of f of x minus f of c all over x minus c. So let's go ahead and apply this into our function. So it's going to be x squared minus 4x. And we're interested in finding the derivative at x equals 3. So what this means is that I'm going to replace this c, since we're talking about an actual x value, we're going to plug in 3. So plugging in 3 into our function in here gives me 3 squared minus 4 times 3, which is a 9 minus 12. That is negative 3. So it's minus 3. Well, it's a minus 3. So that actually becomes a positive 3. So let me go ahead and change that to a positive 3. Okay. So now what we need to do, since if I apply the limit right now in here and here, I'm going to get a 0 over 0. So I need a factor. So this is 3. And factoring these two, let's see, two numbers that multiply, they give me a 3, but when I add it gives me a negative 4. So I'm thinking it's x minus 3, x minus 1. Cancel the two factors. Now we have the limit as x approaches 3 of x minus 1. Now apply the limit. Since we don't get 0 over 0, we get 3 minus 1, which is 2. And that is my f prime of 3. Notice that I verified it using the alternate form definition of derivative, and I still got my same answer here using the regular definition of derivative. So this slope of the tangent line has a slope of positive 2. And then letter D says write the equation of the tangent line that you just found. Leave your equation in point slope form. So we know that our slope of the tangent line is a positive 2. Now we just need an x and y coordinate value. Well, we know what the x value is, since that's what we were trying to find. To find the y value, we got to plug it in into our function, and we already had said that was negative 3. So using the point slope formula, it's y minus 3, which is 2, equals x minus 3, and you're done. So this tangent line here is the line y minus 3 is equal to 2 x minus 3, and you can simplify that and you'll get the y equals mx plus b version. But in calculus you don't need to simplify that, you can leave it alone and you get full credit.